management station can actually request information from the destination. It can modify information. Okay, so GET request is just the management speaking to an agent that's running on a network device and requesting a piece of information, a specific OID. The SET request would be I'm actually modifying it. I'm changing the configuration from a central management station. Get next request, walk is the other term for that. That's basically if you want to start going down through the hierarchy of the management information base. Get bulk requests is I'm just asking for more than one piece of information at a time. And then response. The last one is probably the most important one. That's a trap. And a trap is actually when the agent has been configured to notify the central monitoring station when something occurs. And so this can be very powerful because we're not actively monitoring, but we've set up these alerts, if you want to call them that. That's how they kind of get configured, but then it's a trap message. So the alert gets triggered and the agent knows to send that trap message back to the manager. You notice the trap line there is one way. It's not going from the management to the agent. It is in the reverse. In this chapter, we're going to be looking at network operations and specifically just, some of the things that we do in a network on a daily basis, both to make the network, function efficiently as well as to make sure it continues to function efficiently. In addition to making sure we handle disasters and we handle the load that's required. So it may seem a little bit kind of a hodgepodge, these topics together, but they are all under the network operations section in the objectives. So we will begin by dealing with organizational documents and policies. These are things that the company will put in place to make sure that the network is utilized in the correct way. We'll look at network monitoring, various types of monitoring that we can do to make sure that the network continues to operate at a high level of performance, and also these can be used to troubleshoot when that's not the case. And then high availability and disaster recovery. How do we make sure that the system stays up and running in the case of failure? And if there's a failure, how do we restore the data and services back to the way that they were? In this first topic, we'll be dealing with organizational documents and policies. We need to be able to recognize the purpose of these policies by their name, the functionality that represents, and just give some examples as to what these policies might be used for. Organizational documents and policies help to ensure that employees comprehend what we are supposed to be doing and not doing on the network, as well as making sure that we're utilizing industry standard best practices. From a company perspective, it provides a unified front approach in various areas. It can also help us in troubleshooting, it helps us in monitoring, and in certain cases provide assistance in legal undertakings. Now, there's several different categories of organizational documents and policies, and they don't all, of course, serve the same purpose. So we have plans and procedures, like the steps that we would take in order to ensure that technologies are implemented in a safe and consistent way. We've got hardening and security policies. And those are going to be the organizational steps that we take to make sure that the operating systems are patched and secure passwords are used and things like that. We have network documentation, both logical and physical diagrams, and then you have business agreements that often are used to represent partnerships of the organization. So we'll start with plans and procedures. Again, all of these are really just something that we need to be able to recognize exactly, and know what these mean. Okay, we are not obviously going into detail on any of these, but from the exam objectives, we just need to be able to, kind of recognize the purpose of these. In fact, let me get the exact wording is just explain the purpose of organizational documents and policies. And every one that we're going through in this section is listed in the objectives under 3.2. Okay, so again, not developing them, not understanding the ins and outs, but just being able to determine the difference. So change management is the first. Change management is a formal plan for an organization on how change is to be implemented within the environment. Okay, and a change can be something as little as, a patch on a server, a new hard drive controller, a new network card, to as much as a brand new technology, a brand new partnership connection. All of them are change. Now, the level of change is going to determine the amount of formal planning, but so is the organization. So organizations that use change management do have a formal approach to implementing change within the environment. And it includes documentation, it can include approval processes, it can include testing, it includes rollback plans. It's all about how are we going to manage change. Incident response plan. Incident response plans are related to network security. We can put all the security in place that we want, but we cannot completely eliminate the fact that there may be a breach at some point. A user may make a mistake, click on an email attachment that they shouldn't have. They may get a call from somebody and give out too much information. Well, incident response plans are the steps that will be taken in response to an incident. And the goal would be to contain the security breach as much as possible and recover from it. Disaster recovery plan is just think backups. Okay, disaster recovery is we're going to do backups and put mechanisms in place so that if the organization experiences a loss, physical loss, location loss, we have the ability to recover. And we need disaster recovery plans for all critical applications as well as physical locations. A business continuity plan can include disaster recovery, but it often includes more high availability. That's how are we going to remain operational even in the case of failure. And so we'll have to implement redundant components, redundant servers, redundant network devices, so that if there is a failure, we can remain up and running. System lifecycle, that's more of a plan on utilizing physical resources. Okay, so system lifecycle on applications, system lifecycle on laptops, desktop servers, just the phases and when we would look to upgrade or replace that equipment. And standard operating procedures, that's sort of a very kind of broad term, but it's the organization would come up with standard operating procedures in a lot of different areas, but most specifically probably network administrative things. These are, if we're going to put in a new switch, if we're going to put in a new server, these are the steps that we have to do to make sure that those systems are set up and secure. Now, in hardening and security policies, this is a separate little subcategory. Password policies, obviously here, the point is all around related to security and keeping our systems secure, keeping our accounts secure, those kinds of things. So password policies are a policy that just states the length and complexity of passwords, the amount of time or the age of those passwords before you're required to change them, those kinds of things. Okay, password policies can be an actual policy, a document that we follow, but often they're actually put in place as technical controls as well, meaning that there's something, say on a domain controller like a group policy, that is controlling the complexity of the passwords. We didn't just tell people that you had to do this, we put something in place to enforce it. So the term could be used for both. Acceptable use policy, this one is just a document, but it's a document that outlines the acceptable use of company property, including desktops, servers, networks, maybe mobile devices. It says what you can do and cannot do online, and kind of puts the due diligence on the user. This is typically something that's signed off on as a part of the company handbook or anytime major updates to it are made. And so just the fact that you signed it says you're going to now adhere to it. And if you don't, then there are repercussions. A BYOD, bring your own device policy. This would be a policy that the organization puts in place that says, hey, you can bring mobile devices, tablets, phones, you can connect them to our company systems, or not, possibly, but if you connect them to our systems, that is a BYOD scenario, and this is what you can expect. We will have this control over these devices. We will be able to remotely wipe your mail, for instance. Remote access policy would be policies governing VPN access. Stipulating not only the steps that you would take to get connected to the VPN, but anything else that you would need to be concerned with. Onboarding and offboarding policy is going to be more of an HR, human resources type of thing. could be technical as well, but I mean, these are the steps that we have to take when hiring a person. And these would be also equally important, the steps that we're going to take when we are getting rid of somebody, or somebody has left the company, regardless of if it was on their own or if they were terminated. We need to have steps, especially from a technical standpoint, of what we can do to make sure that those users can't continue to get into our system. A security policy is, that's a vague one as well. It's overarching. Obviously, it would be a policy that is related to network security, but technically, password policies, BYOD, remote access, incident response plans, all of those are security policies, quote unquote. Data loss prevention, DLP. This is another one that can be an actual policy, but also technical controls. DLP is all about not allowing private internal data to go to external users. Or if allowing it, at least controlling what they're able to do. It's preventing data dissemination. Okay, data leakage is another term, and it's a big thing, and a lot of our organizations do it because they have compliance regulations like medical devices under HIPAA, and so they'll put actual technical controls in email systems, file sharing systems to scan and prevent the sharing of certain types of documents with external users. It's very powerful when you're able to do that. So an actual policy describing what we can and can't do, but then technical controls to actually enforce that. So network documentation, this is another type of document that you would want to be familiar with. It's just what they are. Floor plans, just kind of a generic term for the layout of the physical, not the network, but the office. Okay, so the layout of the office and understanding where different systems are, where the printers are, where the servers are. A rack diagram would just be a diagram of a server rack. On a regular server rack, a lot of times you have multiple servers. Servers, if you haven't seen one, doesn't really look like doesn't look like a laptop, doesn't look like a desktop. Often they're kind of skinny and wide, and so you'll have servers sitting on top of one another. You'll have switches, you have firewalls, you have other network devices that are all in the rack, and so having a diagram of what's what, so you're not kind of hunting for names and whatnot, is very useful. IDF and MDF documentation, if you remember, those are the physical LAN wirings, the intermediate distribution frame, the main distribution frame. We talked about it briefly, but that would be a diagram of those core switches and how they physically connect all of the network. Logical wiring, or a logical network diagram, is a diagram that identifies subnets, clients, servers, other very important devices. It's not a physical diagram per se. It's not showing each and every system. It's more about, okay, this subnet is connected to this router is connected to this firewall is connected to the internet. That's a logical network diagram, whereas a wiring diagram is a more physical, showing the wires from the wall jacks to the wiring closet. Site survey reports are generally more about wireless signals. Audit and assessment reports would be if you went through and you were auditing security, okay, and assessing security, then you could just have a document that reported on that, any findings that were needed to be fixed. And then baseline configurations. Baseline configurations from a performance standpoint is, this is the base configuration for all servers. This is the base configuration for all network devices, for all laptops, desktops. The reason to do this is it assists in deploying those devices, and it helps us to do it in a very standardized manner. All right, finally, we had business agreements. Business agreements represent agreements between our organization and other partner organizations, or sometimes even agreements within our organization. Okay, so an NDA would typically be within our organization. You sign a non-disclosure agreement it means that you cannot relate anything of what you are hearing as a part in terms of, say, like our proprietary software or our internal workings as a company. You sign an NDA. You're not to share that information. You're not to take it if you leave and go to another organization. Service level agreement is an SLA. Now, service level agreements are actually agreements that you see all the time. So a vendor would have potentially an SLA to the company in terms of hardware, and that's just how. So if I have Cisco servers, how quickly can I expect a replacement if I have a drive controller go bad? Same thing with network devices. How quickly can I get a replacement? That'd be a type of SLA. Cloud service providers would provide SLAs to companies as well that are using their services. And sometimes that is the level of connectivity. Sometimes it's the level of performance. Of high availability is often expressed in terms of with SLAs. And these are legal binding documents. They actually have ramifications if the provider does not fulfill that service level agreement. Service level agreements can be internal as well. They can be within departments. So the IT department is providing such and such SLA to the marketing department or the sales department and their database that they need. And so we're saying, okay, we're going to have this level of availability. We're going to have this level of performance. Now, a memorandum of understanding is basically the same thing. It's not as legally binding. So SLAs, I know we said internal, but we typically see SLAs between companies, vendors and your company, cloud service provider and your company, co-location and your company. Memorandums of understanding are often a little bit more flexible, less formal, but the same concept just within the organization. In this next topic, we're going to look at network monitoring. It's important to be able to understand the purpose of monitoring as well as the tools that you have at your disposal, whether it's monitoring just to make sure that we are continuing to, the network is continuing to act consistently and perform well, or monitoring because you're trying to troubleshoot. You're still going to use the same tools, and this can be very helpful. So there are different types of monitoring, but the ongoing monitoring of a network is crucial in order to make sure that we have continued efficiency of operations. As a network technician, it's possible for you to be responsible for monitoring in two different scenarios, proactive and reactive. Now, both are beneficial, and both require you to be familiar with monitoring concepts and tools that are involved. However, one is a little better than the other. Proactive is we're going to monitor even when there isn't a problem. We're going to try to detect problems and abnormalities in performance before they actually cause major issues. And so proactive monitoring is the better monitoring approach because you're not just monitoring in reaction to an event. Reactive monitoring is we've had complaints about performance, or we've had complaints about connectivity issues, and so now we're going to go in and monitor. And it's not that that's not useful. It's just proactive monitoring helps us to establish baselines. It helps us to establish the norm, in other words, on the network, and it'll be easier for us to recognize abnormalities, even slight abnormalities. So that kind of brings us to the concept of a baseline. Baseline is critical in any monitoring efforts because baselines represent normal operational values. They also help to assist in the interpretation of real-time data. Now, I've always said in performance monitoring, you can see extremes. I don't have to know what the norm is to know that a network shouldn't be getting pegged at 100%, that a server's hard drive shouldn't be at 100%. I mean, obviously, you can recognize very abnormal values. But without baselines, it is very difficult to recognize slight abnormalities or trends. And so that's where really a baseline can help in the interpretation of real-time data. Performance baselines do need to be assessed over time, and they need to be modified when necessary. If we have network configuration changes, if we need to deploy additional systems or services, anytime there are major changes on the network, we should be reevaluating the baseline. Okay, and so as I said, baselines provide greater capabilities when it comes to trend analysis and gradual changes in both network operations as well as performance. Now, monitoring tools are very important to a network technician. It's also very important to know what you have to work with. Okay, so the tool themselves is important, but it's important that you know what we should be looking for. There's various monitoring methods to monitor and assess the status of network devices and computers. These are going to vary based on device type, based on manufacturers, but just a couple of things that we probably take for granted are things like lights. Okay, lights on network devices and ports that if they are off, that the port is probably dead or it's not connected to a device. On switches, all of the lights on the switch flashing in a pattern, that actually means something. It usually means we have some sort of loop going on, okay? Whereas just regular intermittent flashing green lights, that means it's good. It's actually transmitting data. All right, so you've got those. We've got remote access monitoring. We've got local monitoring utilities. We've got network packet analyzers. The packet analyzers will allow you to actually capture packets that are being sent over the network and examine the contents. And then Windows computers have several monitoring utilities as well. Those will help you analyze overall performance as well as network performance. So let's look at the different monitoring types. Network monitoring tools are going to allow you to capture and analyze network traffic, and that's important for overall monitoring, management, and troubleshooting purposes. There are a number here mentioned, and these are just kind of broad terms. So LAN monitoring would be any monitoring tools like a packet analyzer that is monitoring the local area network. Wireless LAN monitoring tools would be slightly different. They would include things like signal strength. If I'm doing quality of service monitoring, I'm probably trying to ensure the correct level of performance for a particular type of protocol, like voice or video. Bandwidth monitoring, I'm monitoring the available bandwidth. Wide area network monitoring, I'm monitoring those components that connect me to the wide area network. Okay, so again, those are just purposes. These aren't necessarily all different kinds of tools. These are just places within the network that we would monitor. And a lot of monitoring tools are also going to provide alerting capabilities, possibly via email and SMS text messaging. So let's go now with an introduction to network tools based on the purpose of the monitoring or the issue. There are various tools that are available. You just want to be familiar with some of these. So throughput testers, those are going to measure network throughput and capacity. They do that by sending large data files. They're also known as packet flow analyzers. Connection diagnostics has built-in troubleshooting capabilities on a particular type of connection, so usually used for troubleshooting, not just monitoring. Status monitoring could be the link lights. It's just showing you the current status. Traffic monitoring would be looking at the network as a whole and hearing the top devices communicating. And then we've got physical monitoring, environmental monitoring, power monitoring, the range of power, the level of power, so those are different categories. Traffic analysis is the study of a number of different network activities. It helps us to identify inbound and outbound protocols. It helps us to determine if protocols are unidirectional or bidirectional. We can identify open and closed ports and know what the system is listening for. We can validate traffic passing through firewalls. We can trace the path a packet takes on the network and determine network utilization. And there's a couple different tools that fall into this. Packet analyzers or packet sniffers, Ethereal, Wireshark, and others are freely available out on the internet, and they allow you to scan the traffic. Okay, you can use this for troubleshooting connectivity. We can use this to make sure encryption is being used. We can use this just to determine what systems or what programs and protocols are listening on this particular system. A port scanner is going to identify open ports. These could also just be called IP scanners. They'll hit an IP address and they'll try to scan the well-known ports and identify the ports that are open on that destination system. Now that can be used from an attack perspective by a security threat, but it could also just be used as a form of monitoring. And interface monitoring, whether you're monitoring software, you're just monitoring the lights, that's just monitoring your network interfaces that are being used to communicate over the network. Let's talk about some interface statistics. These are things that you can look at in interface monitoring tools. Link state up versus down just means the connection is up or down. the speed that you're getting, the duplex settings. You can have send and receive traffic, so statistics on how much data is sent, how much data is being received. CRC checks would be failures in packets, and that could indicate a failing network device if you're seeing a lot of CRC errors. And then just packet and byte counts on a per protocol basis. All right. Errors and alerts. So those are just kind of the status. Errors and alerts would be CRC errors. The CRC is that, remember, cyclical redundancy check, which is at the end of each frame, and it identifies, or it helps the destination system check the integrity and validate the integrity of the packet as it was sent from the source. And so the CRC errors would be indicating, I said, of potentially network card failing, a device failing, like a switch or a router. If they're going through that, it's a potential for that. Giants and runts. Runts are very small packets that do not reach the limit. There's an error there. A giant is usually in an application that needs a higher MTU, maximum transmission unit. So the name is probably obvious there. They're both errors. Encapsulation errors would be something we would often see in terms of VPNs, where we are encapsulating one type of traffic into another. Environmental monitoring systems are used to physically monitor network servers and devices and help to prevent hardware damage due to environmental threats. So they will have, critical condition alerts in different ranges. You can see their range of looking for and monitoring temperature, humidity, detecting the presence of water, and having the ability to control power to that device, physical security, etc. Typically, we can get into them because they're connected in through a modem or the internet to a management station. We can remotely reboot those devices. These are critical in server rooms and wiring closets because they really represent our only ability to monitor these physical aspects, which obviously can have very negative effects on the network as a whole. One term that you should be familiar with is the term syslog. Syslog is a method that routers and switches can be monitored by. Syslog is vendor neutral, so it's supported across a wide range of devices, and it provides separation from the software that monitors and stores the events and the software that analyzes those events. So you'll have an events manager, an internal system, and you'll have devices, whether it's workstations, application servers, routers, switches, firewalls, that are sending syslog messages to that central device. The messages are labeled, indicating the type of software that generated the message, and they're also assigned a severity level, okay? Emergency, alert, critical, warning, etc. But syslog is just the technology that allows me to collect that information across multiple vendors and across multiple devices. Okay, getting into the actual software that's being used, like the GFI Events Manager, well, that's not that important. Just recognize syslog as that capability to centrally monitor log messages. Network devices like switches and routers, firewalls will have logs as well. Okay, they're gonna, we should be doing log reviews of traffic logs just to identify the traffic that is being sent through the network device. We can have audit logs that show administrative events that have happened. And then again, most of these can be hooked into a centralized syslog server. You want to adjust logging levels. Sometimes the default logging levels don't get you what you need. So we need verbose or debug logging, and that has to be configured on the device. Typically, that's just going to be, when we're doing monitoring from a troubleshooting standpoint. Okay, and then we can also control the severity levels of the types of events that we want to be alerted about. Now, one of the older network management or monitoring protocols is actually called SNMP, Simple Network Management Protocol. This supports the monitoring and management of a wide array of devices, again, very much vendor neutral. It's used primarily to monitor network-connected devices for scenarios that would warrant administrative attention. But SNMP is an application layer protocol. It also defines a database schema and a set of data objects. The database schema and set of objects is the fourth bullet point here. We'll hit it in a minute, called the Management Information Base, or MIB. The protocol is just an application layer protocol. SNMP operates on port 161 and is supported by a large number of systems. Okay, so what are the components? Well, you have the managed device, and the managed device is a desktop, a server, a router, a switch. They are running an SNMP agent. That SNMP agent is, generally speaking, configured with what's called a community name, which is sort of like a grouping for these devices. That agent will then communicate back to a network management station, which is within that same community. The MIB shows information that's available for each individual device. So this is it's a standard that's been developed with SNMP. As I said, SNMP has been around for 20, 30 years. So it defines, all right, on this type of switch, this is the type of information that's available, and this is the structure that you have to use. You see there, it's a hierarchical structure which uses object identifiers, OIDs, and those contain variables that can be read or written by SNMP, but it makes it so that the management station can request a very particular piece of information as long as it knows the OID for that. Well, the OID for that would be defined in the management information base, which is published, for all to see if you're using these devices. Now, in addition to network devices, we want to also monitor the network operating systems on the servers. That's going to be equally important to make sure we have ongoing efficiency and trouble-free environments. There are a number of monitoring tools built into the Windows operating system, and knowledge of these tools is going to be very practical in today's networks because they're sort of like the first place that we go. We'll do a demo and we'll look through them. Task Manager gives us sort of a real-time view of performance in a simplistic fashion. Event Viewer shows me different kinds of logs that are generating or collecting events that are generated by the operating system itself as well as applications. Resource Monitor is sort of a step above Task Manager in that it gives you a little bit more information, and Performance Monitor is kind of the end-all be-all. Both Task Manager and Resource Monitor, you really aren't able to pick what you're looking at. With Performance Monitor, you can choose exactly what type of information you want to collect. And you can also collect it kind of in the background. You can have what are called data collector sets that are running and just gathering all of that info. So all of these tools, very important in a particular scenario. As I said, we'll go and take a look at a demo and walk through their use. In this demonstration, we're going to look at some of the Windows operating system monitoring tools. We briefly described them in the last slide, but I wanted to take a look at them. As I said, these are very practical in today's networks. They're not necessarily network packet analyzers and things like that, but they are still very useful. So let's start with Task Manager. You can get to Task Manager in a number of ways, one of which is just right-click the taskbar and choose Task Manager. Of course, this utility has been around since Windows, really, and provides you with a snapshot of first running processes on the system. But more importantly, on performance, we've got good real-time statistics of CPU, memory, and network utilization. So you can click on each of the individual categories, and you can see the network utilization, send and receive packets, the IP address, IPv6 address, etc., just to measure kind of throughput. Okay. You can also see running services on the system. All right, so if you're trying to analyze to see if you have unnecessary services, that's certainly an area that you can go as well. From the Performance tab, we have a link to open Resource Monitor. Resource Monitor is sort of Task Manager Plus. Okay? It provides a bit more information in the four major categories of CPU, disk, network, and memory. Of course, our primary focus here is on network, but it is useful in those other areas as well to see what is eating up CPU, what is eating up memory, etc. But when we go to the Network tab, we can also see the different processes that are listening, process identifiers, the amount of data that's being sent and received by those individual processes, as well as the remote addresses. Okay, well, sometimes it's local address, sometimes it's remote addresses. If you click over on the Network tab, you get an even more focused view of network activity. And if you look here, you've actually got the TCP connections that are made to this system, and you can see both the local and the remote address. So you can see what is eating up your network bandwidth, what services are running, and you can identify if there are services maybe that aren't necessary. And then we can even go down to listening ports, and we see the individual ports that are being used by a a potential or a particular, I should say, service. So that's Resource Monitor. And then the kind of the end all be all from a performance monitoring standpoint is actually Performance Monitor. So if you just type perf into the search bar there, you'll see Performance Monitor. And the real beauty of this is that it can be used in two different ways. One, we can use it to measure actual real-time traffic. So you can go ahead and click add, and you can add counters. Now, one of the confusing parts of this is the number of counters that you potentially can be looking at, so that can get a little bit overwhelming. But if you're trying to track network activity, then the first thing to do is to choose the right performance object. So we've got objects for TCP, we've got objects for UDP, we've got objects for the network connection itself. And so you expand like network adapter, and we can add bytes sent, bytes received, total, current bandwidth. You can add all of those in. We'll just hit OK, and then it's going to track those. And as you select one, I find it easiest to use the highlighter because it'll highlight that particular, that's the red there, the packets per second, received per second, sent per second, current bandwidth. It's going to highlight all of those, and it gives you some real-time monitoring. But I said there were two use cases for this. One is real-time monitoring. The other is a more proactive monitoring through data collector sets. There are some predefined system data collector sets, like System Performance. And if you go in and look, you'll see that it is tracking the major subsystems of processor, memory, disk, and network, along with all the protocols. And so you can just hit OK, and we could go in and go to the properties of this and set a schedule. Okay, so from a proactive standpoint, we could have scheduled monitoring at different times of the day, and that's going to help us to define a baseline. All right, so just keep that in mind that you can add those. You can configure how long it's going to go. Actually, though, what this ends up being is sort of a starting point. Really, you can just hit start, and it'll produce a report, or you can go to user-defined data collector sets. And then we'll just create a new custom data collector set. Call it my DCS. And we want to create it from a template. And then we just choose the System Performance template, hit next, choose where we want the log data to be saved. And then I'm going to open the properties for that data collector set. Here, then, I can define a schedule. So I'm going to tell it, okay, we're going to start today, and every Monday, Tuesday, Wednesday, Thursday, we're going to start this data collector set at 9 a.m. Okay, hit OK. If you want an additional time, so 12 p.m., for instance, clear the weekends because we don't necessarily care about those so much. And you get the idea. So we can add different times for the day, and then we can go in a stop condition and say, actually, instead of going for 1 minute, we want to go for 15 minutes. Okay. And so now that we've got that, it's got an automatic schedule on it. So it's not going to be running now. Of course, we can start it at any time and then it'll stop on its own, or we can just leave it on that predefined schedule. And then once those have run, you can actually go down here to reports, and you can see any reports that have been generated. And we may not have any here, so we may have to go down to system. Nope, we got nothing. Okay, well, I'll go ahead and start this. It'll go for 1 minute, and then we will be able to see the report. So you can come in after the fact, and you can use this to develop performance baselines for all the major areas of the operating system. But again, the focus here would be on networking. All right, so we do have those capabilities. While we're waiting for that, we'll go to Event Viewer. Event Viewer, you can also just hit the start button and type in event, and it'll come up. So there are 3 primary Windows logs: application, security, and system. The application log has events related to running applications. They come in the types of information, just telling you something happened, warning, kind of warning you of a potential problem in the future, and error. And error events are something that we want to look out for because that generally means that something has failed, an application has failed or had some sort of problem. Now, security logs are a little different in that they monitor security-related events, and that's in conjunction with the audit policy. And so we actually have to set up audit policies, as has already been set up here because it's a domain controller, to track log on, log off, user rights, those kinds of things. And then system log, that's going to be more focused at the main operating system itself. And so same types, information, error, and warning events. In addition to that, you've got applications and services log, so we can go and look at events related to the DNS server, events related to DHCP or Active Directory, and there's all sorts of subcategories in here that you can use to kind of focus in on particular events. When you have an event that you want to look at, you just open it up and it shows some detailed information about the event, what has occurred, the source of the event ID. That event ID can be used on the internet to research if it's actually a problem, what the potential causes and resolutions of that problem would be. So again, event log or event viewer, and the event logs are kind of the first place that you would go if you're experiencing problems that you're trying to troubleshoot, whether it be with the system or with a particular application. All right, let's go back here. Now we've got our performance events. Let's just make sure that that's stopped. Yep, system performance is stopped. And so we can double click on one of these events and it's going to give us a real good report of just general overview here, CPU, network, disk, and memory utilization, but then we can focus in on individual aspects like the network and see counters related to particular protocols, particular interfaces. So as I said, to get a baseline of traffic types, traffic amounts, this is a very useful tool, primarily because it can be used proactively as opposed to just reactively. Performance monitor in real time would be a reactive approach, looking at it as is, whereas the proactive approach would be planned monitoring over time on a scheduled basis. So those are all the utilities. These utilities are available in the client operating systems as well. They're just a little bit more relevant in server operating systems as it relates to monitoring. In addition to operating systems, there's other things that we can monitor. So devices, chassis, those would be the physical devices. And you can monitor, temperature, CPU utilization, memory utilization. Network metrics, bandwidth, latency, and jitter. Bandwidth is, of course, just the amount of available bandwidth that is that you have to utilize. Latency would be the time that it takes, the slowdown from a packet to get from source to destination. So higher latency connections are going to be slower even when they have an effective amount of bandwidth. And then jitter is just going to be a noise. Okay, it's measuring line noise, electrical signal interference, those kinds of things. So jitter, if we're trying to troubleshoot and we see a lot of that, then we need to locate the source of that problem. In addition to proactively monitoring systems, network operating systems and devices require ongoing maintenance known as patch management as well. The goal of patch management solutions is to make sure that operating system patches, software patches, firmware upgrades are deployed in a consistent fashion and devices are kept up to date and protected against failures and other vulnerabilities. So we have operating system updates that are released on an as-needed basis by that vendor. You have firmware updates for switches, routers, access points, etc. You have device driver updates within the operating system for things like a network interface card. Now, all systems are not going to support the same type of patch management. A lot of times network devices, they have to be managed manually and individually, whereas with servers and clients, we can push out patch management policies from a central location like group policy in Active Directory. So that's kind of one of the things that we need to keep in mind. And it's very important because a lot of vulnerabilities are targeting old firmware, or a lot of vulnerabilities are found in firmware that when updated, then that vulnerability no longer exists. Same thing goes with the operating system. So not only from a performance standpoint, but also from a security standpoint, having patch management and consistently putting patches and upgrades on systems is very important. With the operating system, you got minor updates like hot fixes that'll fix errors in operating system code. And these errors are such that have been detected after the OS has been released. Whereas patches are temporary or quick fixes designed to address typically security vulnerabilities or compatibility issues. And updates would enhance the operating system and some of its features, also improving security depending on the situation. Okay. Major updates typically with an operating system is through a service pack. A service pack contains a collection of updates as a single installation. Of course, you also have the newer version of the operating system. This has sort of been combined in Windows 10 and Windows 11. So every 6 months there is a quote-unquote service pack / OS upgrade. It's kind of all of the same thing that you're, in dealing with those later operating systems. Microsoft Update is the method of updating Windows. It's included in all versions of Windows, and it does provide automatic update capabilities. Sometimes network administrators can use group policy in Active Directory environments, and that helps to enforce those policy settings. And corporate networks might utilize patch management systems like WSUS or System Center Configuration Manager. WSUS is Windows Server Update Services, and these have been used historically in Windows networks to make sure that both clients and servers are automatically applying patches. With network devices, again, we're not going to have that centralized patch management, but we still have this necessity to manage those devices. They're controlled by firmware, and so they're subject to the same needs as an operating system, albeit less frequently. Firmware updates should be applied when it's going to give us a new feature, when it's going to address a vulnerability, and whether it's major or minor. You definitely want to read up on the firmware update and see exactly what it's doing to determine if it is something that's necessary. It's also a good idea to always do a backup of the configuration before applying firmware updates, because if we don't, then we can run into issues and a device not being able to be restored. Another key is power. Make sure you don't ever lose power to the device. So if you have a battery backup, you want to plug it in to that as well before you do any firmware updates. In this topic, we're going to be looking at high availability and disaster recovery, both very important concepts in today's networks, both to make sure that we can retain services in the event of hardware or system failures, as well as be able to recover data and services in the case of a more extreme failure. Collectively, these are referred to as business continuity. Business continuity, we mentioned earlier briefly, is a plan and a set of technologies that seeks to maintain the availability of a system using several approaches. High availability is sort of like level 1 protection, and we're trying to implement redundancy as much as possible so that the failure of a single component or service does not bring the system down in its entirety. Disaster recovery more focused on backups and restore procedures so that if our high availability level 1 fails, then we have the ability to get the systems back to a working state. Proactive monitoring is going to be a big part of maintaining business continuity, as is patch management, and we've been discussing kind of the purposes of those in the last topic. So let's start with high availability. High availability, as I said, looks across the network and looks for single points of failure with the goal of eliminating the single point of failure. If you have any single point of failure, then the failure of that device or component would bring the system down, right? And so therefore we want to try to find those single points of failures and eliminate them. Okay, and this is done in various places. So for server hardware, for instance, disk storage, we usually use RAID, redundant array of independent disk. So instead of having a single physical hard drive, you have multiple physical drives that are made into a logical volume. Typically, and it depends on the RAID levels, but that means that you can sustain the failure of at least one drive and still be able to maintain access to that storage. Same thing goes for power supplies. Vast majority of network servers will come already with dual power supplies in them. Okay, we also probably connect those to uninterruptible power supplies, which is a battery backup. We may have standby RAM, that is RAM that's sitting there waiting to be utilized in the case of a failure of a memory chip. Same thing goes for drives. We can have RAID levels, but we also have standby drives that are called hot spares, and those can be activated and utilized in the case of a failure. And then dual NICs set up in a NIC teaming format so that the failure of one of those network cards would not render the device incapable of communicating over the network. With network devices, switches, routers, firewalls, we really just need to have duplicates. We need redundancy in these areas. It's not redundancy within the device itself, it's redundancy in having other network devices that are available. Applications and server roles can be spread across multiple physical servers and set up in load balancing configuration so that the failure of one does not bring the system down. And then data storage, like storage area networks or NAS devices, those can also be duplicated. We can have redundancy. With SANs, we might have two SANs and we're mirroring the data between those two so that either could be used in the case of a failure. So that's what high availability is all about, finding and eliminating single points of failure. So let's talk about some of our options. At the operating system and application level, high availability is going to use various options to make sure services and data are always available. So for instance, multiple servers hosting the same application or service. So maybe it's a web front end to a back end database. Maybe it's a back end database that's mirrored across multiple servers. For the front end, we typically use network load balancing. Okay, so we are distributing packets on a virtual IP address to multiple front end servers. On the back end, we typically use failover clustering. That is, systems that, like in this graphic, have access to the same storage area networks, probably duplicate controllers, but giving them access to the same physical storage. So whether the database is active on one logical server or another, it really doesn't matter. They have access to all of those things. Virtualization can be combined with failover clustering. So virtualization hosts like ESXi servers can be set up in a cluster so that VMs can rapidly be moved from one host to another. And in many cases, these high availability options include some form of data replication. That is simply copying data from one location to another. The type of high availability option that you choose is going to vary based on the scenario. However, all the high availability in the world does not replace the need for comprehensive disaster recovery plans. So that brings us to disaster recovery. Disaster recovery is sort of like your level 2 protection. It seeks to restore the system or data that has been lost to a working state as quickly as possible. The goal with high availability is to never go down, or to go down very infrequently. The goal with disaster recovery is to be able to ensure that we can bring everything back. So disaster recovery utilizes backup systems, and we back up data that can be done either locally or remotely. Servers, of course, they're backing up data stores, databases, etc. Network devices can back up state and configuration to a central location so that can easily be restored. Disaster recovery has the ability to restore individual files, entire databases, and entire servers. Disaster recovery can also come in the form of database duplication and server duplication in alternate locations known as recovery sites. So again, this is going to involve data replication of some sort, where we're replicating the data to a remote location so that if we have a physical or natural disaster that renders our site inaccessible, we can spin those things up at that location. This traditionally was a co-location, basically just a data center that you were renting from somebody. This has sort of evolved now into the utilization of a lot of cloud services for this purpose. We can't seek to eliminate redundant or eliminate single points of failure without looking at the actual hardware. Now, a couple of these we've mentioned. Switches, routers, firewalls should be duplicated. WAN connections or a connection to an ISP, you should have a backup for those. Otherwise, that is a single point of failure. We've mentioned NIC teaming as well. The one we haven't, I don't think, is multipathing, and that's actually what we see on the graphic here. An HBA card is a host bus adapter card that is connected to SAN controllers. Okay, and in what we see here in multipathing is not only do we have duplicate HBA cards, but they have multiple paths to each controller. Okay, so we've got path 1 and path 2 to different switches, and then you've got each individual switch being connected to multiple paths to the SAN controller. That way we don't lose access to our data storage. We need to think about redundancy in facilities and infrastructures as well. We've got the UPS, the uninterruptible Power supply, power distribution units, just a name for power supplies basically. But UPS serves as a battery backup. It gives us a source of clean power usually, but it also can retain a charge so that at the very least we can successfully shut down the servers in a graceful fashion. Generators are required in situations where it's absolutely mandatory to retain power. The UPS isn't really meant to maintain power for long periods of time, whereas generators and backup generators can do that. We need to think about HVAC and fire suppression as well. Not really a network topic per se, but definitely something that has to exist in our facilities and infrastructure to make sure that we can recover from a disaster. Let's talk about some more high availability concepts. I mentioned the other alternate locations. We have cold, warm, and hot site. The difference between these is how long it takes you to restore. So cold sites and cold storage is typically just data backups. It doesn't represent an actual virtual machine that could be stood up, but it does represent an offsite backup that could be used to recover. Warm sites are a little bit closer to a hot site. They have duplicates of our virtual machines, usually replicated in some fashion, as well as duplicates of the data storage, and they could be activated in a short period of time if necessary. A hot site is typically an ongoing replicated object, okay, in the form of a virtual machine that could be immediately turned on within a matter of minutes. For it to be termed a hot site, your RPOs, which is a term we'll talk about here in a little bit, your RPOs usually have to be in less than 5 minutes. Cloud site could be any of these kinds. It's just maintained by a cloud service provider. So Microsoft Azure, for instance, you can store offsite backups through the Azure Backup program. You can also use Azure Site Recovery to replicate entire virtual machines, and that gives you a hot site. Okay, so the difference really is it's a cloud site just means, like I said, it's maintained by a cloud service provider. It's not one of our locations. It's not a co-location. Active-active versus active-passive is another concept that we need to understand. Active-active means we have two separate sites or two separate servers, both of which are actively facilitating client connections. Active-passive means you have that secondary device that's sitting there and waiting, okay, and only becomes active if the other device fails. Now, I keep saying device because I'm thinking servers with active-active, but it could be an application. It could be the ISP. If you have multiple ISPs and they're active-active, that means you're using both of them at any given time. If it's active-passive, then you have a backup that probably through router cost is only chosen if the primary ISP connection goes down. And the next two, virtual router redundancy protocol and first hop redundancy protocol, those are both protocols that are used by routers in an instance where I have set up duplicate routers that are using the same path. So they are used to communicate between the routers to make sure that the appropriate router is chosen at any given time. Here are some other key terms. Mean time to repair. Mean time to repair is a term that's used typically for hardware and in conjunction with SLAs. This is the amount of time that you should expect a replacement or a repair. Mean time between failure is kind of a standard on a certain device that just says, okay, these, they have a lifespan of 3 years, 5 years. That's what you can expect. We don't really have anything to do with MTTR and MTBF. That's really more about the vendors and the physical hardware itself. We do have some control over recovery time objectives and recovery point objectives. Recovery time objectives would be the amount of time it takes to restore data and services in the case of a failure. Recovery point objective is how much data loss should be expected. The lower the RPO, the less data loss. Okay, so if you have a 5-minute RPO, that means you're basically saying at any given point, regardless of the failure, we know we have technologies implemented so that we can recover up to 5 minutes ago, and that's the amount of data loss. So recovery time is how long it's going to take to get it back up and running. Recovery point is how much data we can expect to lose, and you have to design your high availability with these in mind. You have to design your disaster recovery, your backup policies and procedures with those things in mind. In this chapter, we looked at network operations. We started by talking about organizational documents and policies that help companies have a unified approach and utilize standards in order to ensure efficient network communication. We talked about proactive versus reactive network monitoring and various monitoring tools that we have at our disposal, and how those also allow us to make sure that we are achieving a certain standard in network communications and consistently doing so. As do high availability and disaster recovery. High availability seeks to implement redundancy anywhere single points of failure are found on the network, so that the loss of a single component or service does not render the system inaccessible. Disaster recovery utilizes backups in order to ensure that should the system go down, we have the ability to restore and get that data and services up and running.